So today I'm going to be going over how to do problem 4 from the FVISD UAL Practice Contest 2 called Best Sensor. So basically what this problem has you do is for each test case, you're given a list of sensors. And for each sensor, you're given its name and its X, Y, and Z coordinates, which represent the location of that sensor. And then with this list of sensors, you're asked to compute two things. The first is the average location of the sensor. So what that means is the average location's X coordinate is the average of the X coordinates, the average location's Y coordinate is the average of the Y coordinates, and the average location's Z coordinate is the average of the Z coordinates. So for example, in this first test case, if you average 4, 3, and 5, you get 4. If you average 5, 4, and 6, you get 5. And if you average 6, 5, and 7, you get 6. So that's how the average location works. Then the second thing you're asked to compute is the name of the sensor, which is closest to that average location. So in this first sample case, sensor 1 is actually the exact same point, happens to be the exact same point as the average location. So it is the closest to the average location out of all the other sensors. So when I say closest, that's just going by the classic distance formula when applied to three-dimensional coordinates. So basically the solution to this problem is we need to first compute the average location by summing up each type of coordinate, like X, Y, and Z, then dividing by the number of sensors to get the average coordinates, and then we can sort the sensors by their distance to that average location to get what the closest one is. So now I'm going to actually code the solution so that you can see the code for it. So the first thing in the input is the number of test cases. So I'm going to read that in first. And then for each test case, you're first given the number of sensors. So I'm going to call that n. And then we need to actually store the n sensors. So I'm going to make an array of type sensor called sensors. And it's going to have size n because there are n of them. So that means that we're going to need to make a class called sensor to store the attributes of a sensor, which are the name and its X, Y, and Z coordinates. Okay, and then so now we can read in the n sensors. So for each sensor, there's the name and then the X, Y, and Z coordinates. Okay, so then we're going to store this in our array of sensors by creating a new sensor with the attributes that we just read in. So that means we're going to have to also create the constructor method for the class sensor. And then assign the attributes of this instance variable. Okay, and then one other thing we need to keep track of is the sum of each coordinate, so that in the end we can average them by dividing the sums by n. So we also need to keep track of the sum of the x coordinates, the sum of y, and the sum of z. And then at each sensor we need to just update this sum by adding the current coordinates. So then by the end of this for loop, we'll have the sums of the x, y, and z coordinates computed. So now we just need to average them by dividing by, so to compute the average, it would be sum of x divided by n, because there are n sensors. So, and we need to store this in a variable called like avg sub x, but we actually are probably going to make a method here that like computes the distance from a sensor to the average location. So we need to be able to access these variables outside of the main method. So I'm going to actually go ahead and make static variables, and they're of type double because like when we print them out, we need some decimal precision. So I'm going to make double variables called avgx, and then the same for y and z, and then we're just going to assign them over here. We're going to reassign them for each test case. But one thing with this is that this is int over int, which can lead to truncation. So I'm going to put a 1.0 times in the beginning so that this becomes a double, so that this becomes a double. and then do the same thing for the other, for our y and z. Okay, so now we have our average location. Okay, the next thing is to sort the sensors by their distance to this average location. So we're gonna the way I'm gonna implement this is by using a comparator in the method array.sort. One other way to do this is to make the class sensor comparable, and then also include the compare to method. But I'm just gonna do it this way. So basically, what the method compare does is it tells the program how it wants us, like how we want it to sort two sensors. So based on A and B, if the distance to average, like say we're gonna make a method called distance to average of A is less than the distance average to B, then we print some. Then we return some negative number, which is basically telling it to put A before B in the sorted array. And then if it's the other way around, like A is farther than B to the average location, then return 1, making it so that A comes later in the array than B. And then otherwise, just return 0 because they're the same distance. So now we need to actually create the dis to average method. So this is going to return a double. And it's going to take in a sensor called S. So then we just need to basically write this formula where the first point is the sensor S itself, and then the second point is the average location, which we already have the coordinates for. All right, so we can basically write this distance formula, and it actually doesn't matter if you have the square root, because if you have like two distances that are square rooted, if you square them, they'll still have the same relationship. Like if root A is less than root B, then A will also be less than B, assuming they're all positive numbers. So we can just omit the square root just to not have to add that commutation in, and then we just implement the distance formula. So this squared, the difference in the x coordinates squared, and then you add the same for y and z coordinates. Oops. Okay. So by the end of this, we've sorted the sensors based on their distance to the average location, where sensor 0 is the closest one because it's sorted in increasing distance. So now to actually print the output, it wants us to print the name, and then the 3 coordinates runs to 3 decimal places. So I'm going to use printf to format the output because it's a pretty easy way to format output. If you're not familiar with printf, you can search it up because I'm not going to go into depth into printf in this video, but some key things is %.3f rounds a double to 3 decimal places. So that'll be useful in this to format this. And then %s takes in and prints a string. So the string we want to print is sensor0.name. So that because that's the name of the closest sensor to the average location, and then there's the average location's coordinates. And then %n is a new line character. All right, so then that should be the complete solution for this problem. So I'm gonna open a test.in file which already has the sample data, and then run it. Oh, I actually have to change this to read from test.in first. Okay, yeah. So this output seems to match the sample output. So I'm gonna switch it back to system.in and submit the code. All right, and then it's correct. So thank you for watching, and I hope you join us again for future contests.